Space isn't silent. It's filled with an incredible cosmic concert. From the deep bass of black holes to the rhythmic pulses of distant stars, our universe creates a hidden symphony that scientists are just beginning to understand. Back in ancient Greece, around 500 BCE, a mathematician named Pythagoras came up with a fascinating idea. He believed that the planets and stars made beautiful music as they moved through space. Pythagoras noticed that musical notes followed mathematical patterns. Shorter strings made higher notes, while longer strings made lower ones. This led him to think that the planets, which also moved in mathematical patterns, must create their own cosmic music. He called this the music of the spheres. While we now know planets don't actually make music by moving, Pythagoras was onto something important. He was one of the first people to suggest that space, math, and sound were all connected. His ideas influenced scientists and philosophers for over 2,000 years, and in some ways, he wasn't entirely wrong. Space does make its own kind of music, just not the way he imagined. Today, scientists have found a clever way to turn space data into sound. They call it stellar sonification. Think of it like turning a photo into music. When stars pulse, explode, or send out radiation, scientists take this information and convert it into sounds we can hear. It's similar to how your music player turns digital data into songs. For example, when they converted the light from a supernova into sound, it created an eerie rising tone, like a cosmic alarm clock. The Hubble Space Telescope's images of galaxies become beautiful cosmic symphonies when transformed into sound. Even our sun has its own voice. It sounds like a low, constant humming. This isn't just for fun. These sounds help scientists understand space better. Some patterns are easier to spot with our ears than our eyes. Let's talk about some of the most fascinating musicians in space. Pulsating stars. These cosmic drummers, also called variable stars, change their brightness regularly, like a heartbeat in space. Some get brighter and dimmer every few hours, while others take months. The most famous ones are called Cepheid variables, which pulse so regularly you can set your watch by them. When these stars expand, they get brighter, and when they shrink, they get dimmer. It's like a giant cosmic light show timed to a steady beat. Scientists use these stellar rhythms to measure distances in space. The brighter the pulse, the more powerful the star. Think of them as cosmic lighthouses helping us navigate the universe. When we convert their pulsations into sound, they create distinct patterns. Some sound like slow, deep drums, while others make faster, higher-pitched beats. Our sun isn't just a silent ball of fire, it's actually a massive musical instrument. The sun's surface is constantly bubbling with activity, creating sound waves that bounce around inside it. These waves are like deep, low-frequency sound waves, about 20,000 times lower than what human ears can hear. When scientists speed up these vibrations to a range, we can hear the sun sounds like a deep, continuous hum mixed with rumbling sounds. The sun's atmosphere also creates different sounds. Solar flares make what scientists describe as a pop sound, while loops of plasma make whooshing noises. All these sounds come from real movements of gas and energy in the sun. The whole sun acts like a giant speaker, with sound waves bouncing around inside it. These solar sounds aren't just interesting, they help scientists understand what's happening inside our star. Space has some amazing musical partnerships in the form of binary star systems, pairs of stars that dance around each other in an endless cosmic ballet. When scientists convert their movements and interactions into sound, they create beautiful cosmic duets. As these stars orbit each other, they produce regular patterns of light and energy that, when turned into sound, make rising and falling tones. Some binary stars even exchange material, creating a kind of cosmic whistle as gas flows from one star to another. The faster they orbit, the higher the pitch becomes. Some binary systems create deep, slow melodies while others make rapid, high-pitched sounds. These stellar pairs help scientists understand how stars interact and evolve together, like musical partners in perfect harmony. Black holes might seem silent and dark, but they're actually cosmic bass players creating the lowest notes ever detected. In 2003, astronomers found that the black hole at the center of the Perseus galaxy cluster makes a note 57 octaves below middle C. That's way deeper than any sound humans can hear. The sound comes from the black hole sending out powerful waves through the hot gas surrounding it. If we could hear it, it would be like a massive cosmic subwoofer. These space waves act like ripples in a pond, pushing and pulling the gas around the black hole. While we can't hear these super deep sounds directly, scientists use special tools to turn this data into sounds we can hear. When they do this, black holes sound exactly like you'd expect. Deep, powerful, and a bit scary. These cosmic bass notes help scientists learn about how black holes affect the space around them. Let's explore one of the most amazing discoveries in modern science: gravitational waves. These are like ripples in the fabric of space itself, created when massive objects like black holes crash into each other. When scientists first detected these waves in 2015, they could actually turn them into sound, and it made a chirp noise, like a cosmic bird call. These waves are incredibly tiny. They squeeze and stretch space by an amount smaller than an atom. But our special detectors, called LIGO, can catch them. Think of space as a giant drum. When big events happen, like black holes merging, they create sound waves that travel through space-time. While they're not actual sound waves like we hear on Earth, converting them to audio helps scientists study some of the biggest events in space. Let's explore how stars create their own unique music through plasma, the hot, energetic gas that makes up most stars. When plasma moves, it creates waves that act like sound in space. These waves happen when magnetic fields push and pull on the hot gas, like plucking strings on a giant cosmic guitar. In our sun, these plasma waves create different notes depending on how hot the gas is and how strong the magnetic fields are. When scientists convert these waves into sounds we can hear, it creates an otherworldly melody. Sometimes it sounds like ocean waves, other times like wind chimes in a storm. The really cool part is that these plasma songs tell us important things about what's happening inside stars. Different sounds can warn us about upcoming solar flares or help us understand why the sun's outer layer is so incredibly hot. Star clusters are like nature's biggest choir, where thousands of stars work together to create an amazing space symphony. When scientists turn the light and energy from these clusters into sound, each star adds its own note to the mix. Hot, bright stars make high-pitched sounds, while cooler stars create deeper tones. As these stars move around and interact with each other, their combined frequencies create patterns that change over time. In globular clusters, where stars are packed super close together, the sound is rich and full, like a massive orchestra all playing at once. Young star clusters sound different from old ones because their stars move faster and burn hotter. Scientists use these collective star sounds to learn about how clusters form and change over billions of years. The way we listen to space is changing fast, opening up exciting new possibilities for both science and art. Scientists are developing better tools to capture space sounds, helping us spot things like dangerous solar storms earlier. Artists are using these cosmic sounds in amazing ways too, creating music that blends actual star sounds with traditional instruments. Some museums now have space sound rooms where you can walk through a galaxy's worth of stellar music. In research, these sounds help scientists spot patterns they might miss just by looking at data. Imagine wearing special headphones that let you hear changes in space weather in real time, or visiting a planetarium where you can hear every star twinkle with its own unique sound. The future of space music isn't just about discovery, it's about connecting with the universe in a whole new way. Thanks for joining our cosmic concert tour through space. The universe's symphony continues to amaze scientists every day. If you enjoyed this musical journey, hit like, subscribe and share to help others discover space's incredible soundtrack.